Welcome. It's June, so it's time to look back and see what happened to solar cycle 25 during the month of May. And we've had major increases in the amount of activity in terms of the number of sunspot regions, flares, and coronal mass ejections. Let's see what we're going to cover this time around. First, we'll deal with solar cycle 25 so far, discuss the new sunspot regions that appeared, the flares, the coronal mass ejections, and the geomagnetic storms. We're going to have movies of both the optical sun and also the coronal, as well as the coronal mass ejections. And I have movies of each of the 4 M flares that occurred during this month. First, let's take a look at the number of sunspot regions that have emerged during the month of May. We had 21 solar cycle 25 regions, and interestingly, we had one reverse polarity region, which I've marked here in blue as solar cycle 24. However, it was at very, very high latitudes. It's almost tempting to call it the first of solar cycle 26 regions, but that would be ridiculously early. With the 21 regions that we had emerged during this last month, that brings the total for the year to 92. Projecting forward to the end of the year, that would bring our total to 224. Which would be a significant increase over the 165 that we had for 2020. Seeing as we're dealing with sunspots, let's first of all start with the sunspot movie. This is data from the Solar Dynamics Observatory HMI instrument, the optical channel. Note that most of the activity for this month has shifted to the northern hemisphere. It produced 14 sunspot regions, whereas the southern hemisphere, which has been dominant up to now, has only produced 8. Next, we'll take a look at the magnetic movie. Sunspots are manifestations of magnetic field, and there's a mode that the HMI instrument will show you magnetic field. The northern hemisphere dominated during the month, as you can see here. You can see that there are more magnetic regions than sunspot regions for the equivalent time. That's because not all regions produce sunspots. And there are different stages of evolution here. Top here you can see what is called a bipole. That's just a very simple north-south change. However, this is the region I was talking about earlier. There was very, very high latitude region and reverse polarity. Here you can see emergence of a new strong region with, then we have 2 older regions which begin to spread out and deteriorate. And eventually they look rather like this plage region down here, which is spread out over a very long range of latitudes and longitudes. Next, we'll take a look at the transition region of the Sun. This will use the AIA helium-2304 image. Now, the surface of the Sun is about 6,000 degrees Kelvin, and the corona, a few thousand kilometers above it, is at several million degrees Kelvin. So there's a transition region where the temperature increases very rapidly and the density drops very rapidly. And that's what the transition region is. The temperature of this particular line is about 50,000 degrees Kelvin, which is plenty hot enough, but it's neither surface nor coronal material. Now, what you want to look for are eruptions of filaments and prominences from this. Prominences are these bright areas that stick up above the limb of the Sun. You can see some on the other limb as well. Filaments are the dark areas that I've pointed to here with these arrows. And in some places you can see where a filament is dark on the disk and is bright on the limb. Now that's because they're actually in fact the same thing, and when you see one on the disk it's a filament, when you see it on the limb it's a prominence. Next, we'll take a look at the low corona. This is going to be using the AIA instrument 171 angstrom channel, shown here on the right. That's about 650,000 degrees Kelvin, so that's significantly hotter than the transition region, but not quite up to the temperatures of the lower corona, which makes this a particularly interesting area to look. So you're seeing cooler magnetic loops here, joining these sunspots. Look for those loops and see changes in them as they cross the disk. Next, we'll take a look at the so-called quiet corona. This uses the 193 angstrom channel of the AIA instrument. It's at about 1.2 million degrees Kelvin, so it's about twice as hot as the previous channel. Now, these dark areas here are coronal holes. They are areas of open magnetic field that allows the high-speed solar wind to stream out into the solar system. And the last thing to note is that the sunspot regions now appear bright. This is because they're hotter and they're giving more emission in these X-ray regions. Next, we'll go from the quiet corona, or the so-called quiet corona, which when you look at it isn't all that quiet, to what's called the active corona. For that, we'll go to the 335 angstrom channel of AIA. That is a temperature of about 2.5 million degrees Kelvin. Active regions appear very bright, and flares appear as short-lived flashes of bright light. May do as far as flares are concerned. Well, it was very productive. It had produced a total of 47 flares, 4 of which were M flares, and that's more M flares than we've had so far during this cycle. So it was very active, and it was second only to November of 2020 in terms of the absolute number of flares. So if we want to see the flares, then we go to a different channel yet again. This is the 94 angstrom channel on the AIA instrument. The temperature here is about 7 megakelvin. Flares appear as short-lived flashes, as shown here. Next, we're going to take a look at each of the individual M flares as a movie. This is the first one, as I said, on the 7th of May. It was the second largest flare of solar cycle 25 so far. It's from NOAA region 2822. Here's the light curve from the GOES X-ray instrument. You can see it goes up into the M class and was classified as an R1 event. It started at 1843 UT, peaked at 1904 UT, and dropped below M level by 1919 UT. It was an M 3.9 flare. It induced a CME, as we shall see later, a very impressive event going off of the east limb of the sun. We're going to have 2 movies of it. One is the 171 angstrom coronal loop dynamics and Morton wave movie. And the other one is going to show the flare plasma in the 131 channel. The next M flare of that month was on the 22nd of May. It was the 5th largest flare of solar cycle 25 so far. There's a picture of it here in the 94 angstrom channel. It was from region 2824. It was an M1.1 flare that peaked at 1711 UT. Again, we're going to show the same two movies, showing one the loop dynamics of the event itself. You will notice two brightenings, one towards the beginning, that's the flare I just talked about, one towards the end, which is the flare that comes next. And then secondly, the flare plasma around about 10 million degrees or so. Again, note there will be two flares. The first one is the flare we just talked about, and the second one is the one that will be coming next. This light curve might seem a little deja vu, but a few hours after the M1.1 flare, we had an M1.4 flare. It was also from the same region, 2824. It peaked at 2136. Last but not least, on the 23rd of May, we had another M flare. It was the 4th largest M flare of solar cycle 25 so far. It was from region 2824. Again, it was an M1.2 flare and peaked at 1108 UT on the 28th. Again, I'll show the same two movies. Well, we're going to look at the coronal mass ejections now, and there were quite a few of those in the month. There were 47 CMEs in the month, compared with 31 in April. That's a 52% increase. And I'm only going to show the C4 field of view. That's the outer blue field of view. So what conclusions can we draw from all of this? Well, first of all, the obvious one is that solar cycle 25 is continuing to build. We're getting more newly emerging active regions, larger and longer lived sunspot groups, more and larger flares, and more coronal mass ejections. We did have 3 geomagnetic storms in the month, which I think is down by 1 compared with last month, but one of them was a G3 event, which is a much stronger geomagnetic storm. I will likely go to doing weekly reports now, seeing there's so much going on and these reports are taking so long, but you can see daily reports on my Twitter channel, DRK Strong, for breaking news. So stay safe, and until next time, goodbye.